Thank you for your attending, and thank you to all participants in Code Blue. As was just mentioned, I'm Nakatsuru from JP13. Today, I'm so nervous because there are two reasons. The first is I'm a final speaker, and and I'm only one Japanese speaker that speaks in English. そうですね、こっち英語です。そうはい。So my presentation today is about Citadel malware in depth. 大丈夫かな？お、固まった。
It's frozen.
Agenda, I will talk about incidents related to Citadel in Japan and details of Citadel obtained through our analysis. Finally, I will introduce my decryption tool. Okay, let's get started. First of all, let me introduce myself. Again, my name is Nakatsuru, and I come from CC Analysis Center. My primary responsibilities are to analyze malware abused in highly sophisticated cyber attacks, along with R&D on advanced counter malware technologies and cutting-edge incident handling methods. And I have a Twitter account where I tweet about malware analysis and so on. They are mainly in Japanese, but if you are interested, please follow me. In addition, I have got married 2 weeks ago. Thank you very much. Here is an introduction of JP13. I don't skip like CB13. As a point of contact for the CSERTs in Japan and worldwide, JP13 coordinates with network service providers and security vendors and government agencies, as well as the industry associations to combat cyber attacks. Before I get into the details of Citadel, I'd like to talk about Japanese incidents related to Citadel. According to National Police Agency Japan, the amount of illegal transfer has been increasing in recent years. In 2011, the damage of illegal transfer was about $3 million. In 2012, it decreased. However, in 2013, it reached over $14 million. And there are 32 targeted banks, including Japanese mega banks and local banks. What is the cause of illegal transfer? In the same document, our National Police Agency said that in most cases, account information leakage caused by malware. There have been a lot of password stealing malware called InfoStealer. However, this was not exactly involved in these incidents I just mentioned. Behind the incidents, there is a specific kind of malware that attempts to steal internet banking account information. It is called banking Trojan. There are some examples of banking Trojan. The most famous one is Zeus. In Japan, the first Zeus targeting Japanese banks was found in around 2011. And there are Zeus variants. Zeus source code was leaked in 2011. This actually made many Zeus variants. Citadel is one of the variants, and I will talk about it now. Let's look into some actual Citadel incidents. Several antivirus vendors reported about Citadel incidents in Japan. In this blog, according to Trend Michael, there were 20 million infected PCs in Japan. Of course, at JP13, we have been receiving many reports about Citadel incidents from 2012. This picture shows an overview of banking Trojan incident. First, attackers create malware client using a builder. Then they attempt to infect the malware in the user's machine through several methods, such as spam emails. When the user's machine is infected, the malware connects to the web panel prepared by the attackers. In this way, they can take the control of the infected computers, even remotely. When the user tries to connect to the internet banking site, the malware shows a forged message that asks to fill in their account information, which is sent to the attacker server. The feature was originated by Banking Trojan. The feature, which is called Web Injects on Citadel, defaces web pages on web browser. Banking Trojan, such as Citadel, keeps monitoring web browsers on infected PCs. If a user connects to the internet banking using the web browser, it communicates normally with servers. The malware does not do anything yet. After that, when the browser tries to show the banking web page, the malware injects additional web contents there. This is how the users see a defaced web page on the screen. For example, it is possible to inject a pop-up window that asks to fill in the answers for their secret questions after asking for usernames and passwords. This way, attackers can have access to the personal page from any computers. Let's see a web inject demo. Unfortunately, we cannot show you an actual infected sample. I'll show a dummy internet banking site today. Before infection, I will show you actual dummy website. Sorry. When the user logs in,
Ask him what's going on. Don't look at the left-hand side much.
It's shown. And then I execute Citadel. As you can see, Citadel on desktop. After deletion Citadel on desktop, let's see the internet banking. This time we can see a pop-up window when logging in. Whether double-think that is an authentic page or that this user may end up in filling in all of their information. That's how web injects work. Next, I'll show you a Citadel builder and a web panel to control Citadel. This picture is Citadel builder. You can make Citadel easily by just pressing build button after editing configuration files. This is a Citadel web panel. Citadel attempts to connect to the web panel after infection, sends information of infected machines, and receives bot commands. Such tools are easily available at underground market. There are several ways, for example, to sell builder and web panel, and rent a server that pre-installed a web panel. I found that a pre-installed server was available for rent for $500 per month. Information retrieved by Citadel was also sold online. In this case, it just costed about $25 per gigabyte. We convert this type of incidents using our own incident response methods. For instance, we track the servers of Citadel communication, and we request administrators of those IP addresses to suspend the servers. Also, we share information of targeted banks and details of Citadel with relevant institutions. For such activities, we need a variety of information. How the user was infected, where the servers are located, and which sites are targeted for web injects. To retrieve such information smoothly, we did a deep analysis of Citadel. From now, I'd like to talk about further details of Citadel, especially encryption. Here is some useful information on Citadel analysis. Especially the source code was a great help for analysis. And I have to say special thanks to Sophos and Lexi for the useful information about Citadel encryption. Here is a summary of analysis methods. There are 3 analysis methods in general. Surface analysis means gathering information of files and some data available on the internet. It is easy and quick. Runtime analysis means monitoring malware behavior using monitoring tools and sandbox and debugger. Static analysis is given by reading code without running the malware. using IDA Pro. It is the most difficult and time-consuming. In Citadel analysis, mainly I did static analysis. This is the source code and assembly code of this compiled from the source code. And this is assembly code of Citadel. By differing with this, there was no need to analyze common functions. And I could understand Citadel's specific features in a short time. From now, I will show you analysis results. This picture shows Citadel behavior overview. After execution, Citadel installs itself to application.dat folder. The installed Citadel makes an inject of Citadel code to all processes. Injected process attempts to retrieve user information and save it into a sending report. Specific process in XP, it is Explorer, downloads a configuration file and additional modules first. Then it connects to a web panel using the sending report. Download configuration file is saved in registry, and it contains settings of web injects. Next, configuration files. There are two configuration files used in Citadel. First one is base config. It contains initial settings and hard-coded in Citadel binary after encoding. Another one is dynamic config. It is downloaded from an URL stored in base config. In overview picture that I showed just now, the downloaded configuration file is a dynamic config. It contains not only settings of web injects, but also an URL of web panel and settings of other features. Let's look into details. These entries are in base config. There are two important entries. URL config shows URLs of dynamic config. Citadel tries to download an encrypted dynamic config through post request. And encryption key is a keyword for making encryption key. Based on the keyword, RC4 key is generated, and AS key is generated using the RC4 key. Next, these entries are in dynamic config. Dynamic config contains an URL of web panel and settings of several functions. The most important one for us is web injects. When we create Citadel using the builder, we have to load web inject settings into another file. This is a setting. Web injects need parameters such as target URLs and data before injection and data to inject. Citadel attempts to inject password form into Wells Fargo website by default. From here, I will explain about Citadel encryption. Citadel has encryption features. Encryption targets are files and registry entries, and communication data. We have to decrypt all of them in order to retrieve important information for incidental response. Okay, let's see some actual data. Here is some captured communication data. Citadel communicates encrypted data with the servers through HTTP request. Next is an encrypted file. This is sending report created by Citadel. As you can see, we cannot understand what data is stored. At last, registry entries. Citadel saves several configurations as registry entries. They are also encrypted. This is a summary of encrypted data. In communication data, these files are encrypted. Report file, dynamic config, and additional modules. In file, there are sending reports and backup of modules. In registry, there are current settings and backup of dynamic config. We want to decrypt dynamic config especially. This is because we can catch an URL of web panel and last settings of web injects, which is very important. From here, I will explain encryption methods. Here is a summary of encryption methods, and there are 4 methods used by Citadel. First one is AES Plus, which I just named. The old version of Citadel used pure AES encryption. However, recent version of Citadel combines AES and XOR encoding. This is why I named this AES Plus. Second one is RC4 Plus. RC4 encryption, which is also upgraded to XOR mixed encryption. Third one is RC4 Plus Double, which gives double encryption of RC4 Plus. After the first RC4 Plus encryption, this gives another encryption to the data and the key. The last one is installed data. It is AES Plus encryption using a randomly generated key. I will talk about further details later. For decryption, we have to understand all of these methods. For decryption, we have to understand data formats used in Citadel. Citadel uses 2 data formats, bin storage and storage array. Bin storage consists of header-end items, and several items are compressed by UCL. And it is usually encrypted. Storage array is an array of encrypted bin storage. Among encrypted bin storages, XOR encoded bin storage size is stored. For example, let me explain about a case of dynamic config encryption. Base config, which contains an encryption key, is XOR encoded and stored in Citadel binary. Dynamic config is in bin storage format, and several items such as web inject settings are UCL compressed. Before uploading dynamic config to a server, dynamic config is encrypted by AS Plus. At last, I have to explain about overlay. Citadel has encrypted data at the end of executable files. The data called overlay is very important for Citadel. Before installation, Citadel has XOR encoded functions used for install. The overlay contains its XOR key. After that, the overlay holds an even more important role. The overlay has installed information such as install passes. This prevents installed Citadel from being executed on other machines. And it has randomly generated keys such as AS key and XOR key for storage array size. This makes it difficult to decrypt data on other machines. To sum up, we also need to retrieve overlay, which is called installed data, in order to decrypt several kinds of data. That's all about the Citadel encryption. This chart shows a summary of Citadel encryption. You can understand what format and encryption method are used in each kind of data. We need this information for our decryption tool, which will be explained next. Okay, let's see the making of our Citadel decryptor. Our goal in developing this tool is to easily retrieve information from encrypted data for instant response. For implementation, I used Python, like Otsubo-san. I started as a standard language for malware analysis. I also use PyCrypt, which is an encryption module of Python. And P5 for passing Windows executable. And UCL library for decompression. At first, let's implement decrypt functions. RC4 plus process starts from retrieving RC4 key stream from base config. Then given an RC4 decryption and XOR decoding called visual decrypt to retrieve the original data. However, it is not RC4 plus. Let's look into the assembly code. Can you see the difference to pure RC4? Yes, in RC4 loop, we can see XOR decode using specific string. This is why this is called RC4 plus. The string used for XOR decode in RC4 is called login key. Now onto the implementation. Citadel uses RC4 key stream, not RC4 key. And XOR decoding is inside RC4 decryption loop. So I have to implement RC4 decryption manually without PyCrypt. In this code, XOR decoding is shown in red. Next is AS Plus implementation. AS Plus process starts with getting an AS key. and decrypt data using AES EBC mode and Visual Decrypt. It is also modified from pure AES encryption. This is assembly code for AES decryption. As you can see, 32 bytes XOR decoding is added. I implemented AES Plus like this. Fortunately, I did not need to implement AES manually. I could just use PyCrypt. There is no problem in XOR decoding even after AES decryption. Now we have implemented decrypt functions. Next, we want to retrieve parameters required for decryption. As you can see, we have to retrieve many parameters to decrypt all of the encrypted data. And these parameters are in different position, different offset and value in each sample. Of course, we can retrieve the parameters through analyzing decrypt functions. However, that is not what we want. So I use regular expressions to retrieve the parameters by matching binary pattern around the parameters. For example, this is get base config function. We can see the size and offset or base config in this function. To retrieve them, I wrote a regular expressions pattern like this. I also wrote several other patterns for retrieving other parameters. Unfortunately, there is a disadvantage for using this method. It is that we need to unpack Citadel. Most of malware is packed to prevent analysis. However, this method uses Citadel code pattern, so we have to unpack Citadel binary. Now, we completed the implement decryption process. Finally, we have to decompress items in bin storage. Citadel uses UCL library for compression. It is an open source compression algorithm. As you can see, it has complex code. In this tool, I implemented UCL decompress function using C-types. The C-types Python standard library can load DLL files and provide Python interfaces to control them. Thanks to C-types, I was able to call the decompress function directly from our tool. Well, now let me show you how the tool works. These are requirements of environment. The tool is only available for 32-bit Windows. If you can compile a 64-bit UCL library, you can use tool on 64-bit environment, maybe. Next is data requirements. Of course, we need some encrypted data that you want to decrypt. And as I mentioned, it needs unpacked Citadel binary. I will show an easy unpacking demo later. Depends on the data. It needs installed Citadel that contains installed data overlay. This is my Citadel decryptor, just named Citadel decryptor. As you can see, there are many options in this tool. However, you don't need to understand all of them. This is a cheat sheet for decryption. You just need the cheat sheet for using Citadel decryptor normally. Installed data is necessary for decrypting files and registry entries because there are the data left in infected machines. Okay, demo time. I'll show you how to unpack Citadel and gathering encrypted data and decrypt some. These files are Citadel decryptor. There are 3 files. Citadel decryptor main module and module for passing this bin storage and storage array, and UCL library. And there are some data that encrypted by Citadel. The files from infected machine and dynamic config downloaded from the server. And registry entries from infected machine. Okay, before decryption, let's unpack the Citadel. If you use Citadel decryptor before unpack, it shows error messages like this. As you can see, error messages that base config search failed. So it means the binary ry and y.exe is packed. So I'll show you unpack demo using Ori debugger. The most easy way to unpack Citadel to set breakpoint on Windows API. In this case, I set a breakpoint on write process memory and create process W. Then run. Okay, it breaked on write process memory. Let's look into buffer to write. As you can see, there is a header of P file format, Windows executable file. And it is not allocated on virtual memory because text section, code section starts offset 400. Here it's unpacked the Citadel. So next, dump. And next step, trimming. There are junk data. So I told him the data using file insight. File insight is useful for understanding P-file format, such like this. And let's look at the end of file. Here you can see overlay. Okay, here is actually the end of Citadel, finally. Okay, trimming is done. So check again. Here, in this time, we can see try to unpack message. That means it succeeded to search base config and several parameters. Okay, from now, let's decrypt many encrypted data. First target is dynamic config downloaded from our server. As you can see, it is encrypted. In case of dynamic config, we have to use -d decompress option. Yeah, succeed decompress. So let's look the decrypted files. Here, as you can see, an URL of web panel. And settings of several features. At the end of file, we can see web inject settings. Okay, next target is sending a report. Sending a report is in bin storage array format. So we have to need installed data. So -a storage array option and -i installed data. And encrypted data and unpacked Citadel. Okay, let's see decrypted data. Yeah, as you can see, there are many results of command line. Yeah, email account and list of process and results of IP config and installed applications. Okay, at last, registry entries. This file is exported using regedit. As you can see, unknown binary data in this file. Citadel create registry entries such like this. First, save it ANSI text file as an ANSI text file. And convert text to binary using a file insert plugin that made by Mr. Mantani. It's so useful. Yeah, now I got binary data. Okay, save. And let's decrypt. This entry needs -D option because it is dynamic config backup, and -I option. Okay, let's see decrypted dot. Now we are decrypted dynamic config. Okay, that's all. These are some tips for unpacking and gathering that I just explained. I think it will be useful for beginners. Host time. That's all for my study decryptor. In this slide, I will talk about our future tasks. JPSART Analysis Center already has decryption tools for major banking Trojan. However, we don't have ones for game over. Game over is increasing as a recent banking Trojan in the world. And I assume it could soon be spread among Japanese banks. That is why we really want to game over decryptor at the earliest possible time. Thank you very much for your attention. If you want to use the decryptor or to understand more further details of banking Trojan, please contact me. And of course, incident reports can be sent to our incident response team. Thank you very much.
Any 日本国外のやつもここにアナウンスされると困るような気がしますけれども、何か質問ある方いらっしゃいますか？
Any questions?
So I'm not very familiar with internet banking in Japan, but in Europe, for example, the two-factor authentication is getting introduced.
Yeah.
And does that help against web injects and such problems?
日本語でいいですか？
いいです。
その通りだと思います。話を聞くと、いろいろと対策が進んでいて、そういったこともやっているそうです。ただ それで今イリーガルトランスファーがなくなっているわけではないという状況だそうです。はい、
他に質問のある方はいらっしゃいますでしょうか。
非常に分かりやすかったご説明でした。で私もちょっと自分のその会社で、とある銀行さん相手に、ちょっと仕事をしている関係もあって、もちろんユーザー側が、気をつけなければいけないというお話はもちろんそれはごもっともだとは思うんですけれども、企業として、実際にそのウェブネットの部分を、いかに強固にするか。もちろんこのウイルス感染の部分もそうなんですけれども、単純にその和風を入れるとかですね、二要素認証を入れるとか、それだけでは、やっぱりちょっとまだまだ対策としては不十分なところがあるのかなと、思ってます。もし、ぜひそのウェブネットっていう部分の観点でもし何かこういう対策を、銀行側が、こういうふうに取っていくのがいいんじゃないかっていう、なんかそういうお考えがあればお聞かせいただければと思います。
そうですね、難しい質問ですね。そうですね、特にその大きな銀行の、サイトとか、それのインシデントに対応している人たちとか、そういった場合ですと、もうそういった多分、言われたような対策とか、そういったところっていうのは結構進んでいて、今そのもう少し小さな銀行さんとか、多分そういう対策を進めているという段階で、その決定的なこれさえすれば大丈夫みたいなのは、私からしても現状言えない状況だと思っています。なのでこういうことをちゃんと知った上で、それに必要な、それを正しくブロックできるようなそういった対策を、してほしいなとは思っています。はい、これぐらいでよろしいでしょうか。
その他質問はございますでしょうか。
今回ご紹介いただいたシタデルディクリプターは、感染した端末にある、不審なファイルを、ディクリプションする、目的だったと思うんですけれども、もし、通信をキャプチャーしていて、発見した不審な、パケット内容を、ディクリプションすることは可能でしょうか。
そうですね、今回のデモではですね、一応その通信データとして、エンクリプトされたダイナミックコンフィグを取り上げたんですが、それと同様の方法で、シタデルが送った情報もデクリプト可能です。はい、
なるほど、ありがとうございます。
その他どなたか質問ある方はないですかね。では改めまして中鶴さんありがとうございました。
Thank you very much.